In this video, let's practice applying our understanding of linear systems of equations to this rectangular perimeter problem. Now, as always, if you want to go ahead and try this problem on your own first, pause the video now before we go ahead and do it together. If you ever feel like you need to pause and think and try to write something out, go ahead and pause the video as needed. Otherwise, let's go ahead and do some math together. Alright, so we're told that we have a rectangle that has a perimeter of 18 inches. Then we're told that we have a new rectangle that's going to be formed by doubling the width, W, and tripling the length, L. The new rectangle is going to have a perimeter of P, which is going to be 46 inches. We're going to go ahead and write and solve a system of linear equations to find the length and width of the original rectangle, and then find the length and width of that new rectangle. Alright, so for the original rectangle, how are we going to show the perimeter of that? Well, remember, the perimeter of a rectangle is going to be 2 times whatever the length is, plus 2 times whatever the width is. So if we're told in the problem that the perimeter of this rectangle is 18 inches, let's just go ahead and replace P with 18 and say 18 is equal to 2L plus 2W. And while it's totally fine to use this equation going forward, we can also just divide both sides of the equation just to simplify it a little bit, just so we have a little bit easier of numbers to work with. So when we do that, we're going to get 9 is equal to L plus W. So we're going to go ahead and use this one. Alright, so that's going to be one of our equations for our system. Now, what about our new rectangle? Well, the new rectangle is still going to have the same formula for perimeter, which is 2 times the length plus 2 times the width. And what do we know about this new rectangle? Well, we do know the perimeter is going to be 46 inches, so we can go ahead and replace that P with 46. And what do we know about the length and the width? Well, we also are told here that we can find this new rectangle if we go ahead and double the width. So if we double the width, we're going to multiply that by 2. And we're also going to be tripling the length, so we're going to multiply that by 3. So in this case, we're going to have 2 of what? Well, instead of the regular length that we had in the original formula, we're going to be tripling it, so we're going to have 3L. Okay, and then for the width, we know we're going to be doubling that, so we're going to have 2 of these double widths. So we're going to have 2 of these 2Ws. Now we can just go ahead and simplify this a bit by multiplying 2 of these 3Ws together and 2 of these 2Ws together. And if we go ahead and do that, we're going to say 46 for this new rectangle. The perimeter is going to be equal to 6L plus 4W. Similar to that equation that we dealt with for the original rectangle, we can go ahead and simplify this a bit as well and divide by a common factor of all the terms here. So I'm going to go ahead and divide everything by 2. And if we do that, we can use this equation of 23 is equal to 3L plus 2W. This will be our second equation. So now that we have 2 equations here, let's go ahead and set it up as a system. So we can say here that we have 9 is equal to L plus W. And then we can also say here that 23 is equal to 3L plus 2W. So this will be our system. Now at this point, you can feel free to solve this system however you would like to. You can go ahead and solving it maybe by using substitution, or you can use elimination. I think in this case, because everything's lined up in standard form already, just the constants are on the left side of the equation, which is fine. Everything is lined up though. I'm going to go ahead and use that elimination method instead of substitution. So I think I'm going to go ahead and eliminate the W's. So I'm going to go ahead and multiply the whole top equation by 2. Let's go ahead and multiply it by 2. If we do that, we're going to get 18 is equal to 2L plus 2W. And then that bottom equation is just going to stay the same as 23 is equal to 3L plus 2W. All right, so this is going to be our system that we can go ahead and use elimination for. So if we go ahead and notice that we have these common coefficients here, which was what we just did intentionally so that we could go ahead and use elimination. So on the left side, 18 minus 23 is going to be negative 5. And on the right side, 2L minus 3L is going to be negative 1L, or just negative L. And if we divide both sides by negative 1, we can see the length is going to equal 5. Now, if we know the length here is equal to 5, we can go ahead and plug that into this equation right here. So that's going to be 5. So if we say 5 plus W is equal to 9, then W must equal 4. So we can say W is equal to 4. Alright, so for the original rectangle, we know that the length is going to be equal to 5 inches, and then we also know that the width is going to be equal to 4 inches. And then for the new rectangle, which we know the length is going to be tripled, is going to be equal to 15 inches, and the width, which is going to be double that we said, it's going to be double 4, that's going to be 8 inches. And so if we visually want to see what this looks like for the original rectangle, if we have 5 and 4, and 5 and 4, if you tried to find the perimeter of this, you can see that 5 plus 5 is going to be 10, and then 4 plus 4 is going to be 8, so 10 plus 8 does get you a perimeter of 18 for the original rectangle. And then for that new rectangle, we know the length is 15 and the width is 8. So if we see here that the 15 is triple the 5 and the 8 is double the 4, does this equal a perimeter of 46 here? Well, 15 and 15 makes 30, and then 8 and 8 makes 16, and 30 and 16 make a total of 46. So that does match the perimeter of this new rectangle. So these were the two linear equations we came up with to represent the perimeter of each of the rectangles. We used this system and we used elimination to find out that L and W, what their values were. We used that to find out the length and width of the original rectangle, and then we could apply that to find the dimensions of that new rectangle. And then over here, we just kind of drew them out just so we can see visually that everything checks out. And so that just about wraps up this practice problem dealing with linear systems applied to geometry. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.